So hey students, today we are going to do some MCQs from chemical bonding and molecular structure, and it will be whole NCERT exemplar MCQs. So our first question goes to this one. Isostructural species are those which have same shape and hybridization. Among the following species, identify the isostructural pair. So our answer is BF4 and NH4 plus, because in BF4 minus you can see half 3 plus 4 plus 1, that is 8 upon 2, that is 4, that is sp3 hybridization, and it is tetrahedral. Okay, and in case of NH4 plus, half 5 plus 4 minus 1, that is 4 sp3. Okay, and it is also tetrahedral. Okay, polarity in a molecule, and hence the dipole moment depends primarily on electronegativity of the constituent atoms and shape of molecule. Which of the following has highest dipole moment? Highest dipole moment is present in H2O, because it is what its hybridization and shape is, you can see there is sp3 4. So what happens is that oxygen, okay, and here you can see like this. So overall dipole moment is towards the electrons, unpaired electrons too. So it is shape of bent shape. Okay, the type of hybrid orbitals of nitrogen in NO2 plus and NO3 minus and NH4 plus. So let's find it. In NO2 plus, half 5 minus 1, that is 4 upon 2, that is 2, that is sp. And in NO3 half 5 plus 1, that is 6 upon 2, that is 3 sp2. Okay, and in case of NH4, half 5 plus 4 minus 1, that is 4, that is sp3. So our answer goes to sp, sp2 and sp3. So let's find it, that is this one. Okay, hydrogen bonds are formed in many compounds H2O, HF, NH3. The boiling point of such compounds depend on large extent on the strength of hydrogen bond and the number of hydrogen bonds. The correct decreasing order of boiling point of the above compounds is, so this one is the, because of extensive bonding and electronegativity is also one of the factors. Okay, in PO4 3 minus ion, the formal charge on oxygen atom of PO bond is, so our answer is 2, that is minus 1. How we can find it? Like 5 minus so for firstly let's find the hybridization. 5 plus 3, that is 8 upon 2, that is 4 sp3. Okay, and 8 2, so it is tetrahedral. And what we gonna do is like this: P double bond O double bond O double bond O and double bond O. But what happens is that you can 6 minus 5. Okay, what we will do is central atom charge minus the peripheral atoms valence electrons. Okay, valence electrons. So it comes to be 5 minus 6, that is minus 1. Okay, in NO3 minus ion, the number of bonds pairs and lone pairs of electron on nitrogen atoms are, so firstly we will do the hybridization. 5 plus 1 equal to 6 upon 2, that is 3 sp2. Okay, so sp2, and it is, our answer is 4, that is no lone pairs are present on nitrogen atoms, and there are number of bond pairs is 4. How we can see like this? Which of the following species has tetrahedral geometry? So BH4 half, 3 plus 4 plus 1, that is 4 sp3, so it is tetrahedral. Okay, the number of pi bonds and sigma bonds in the following structure is, so we have to count it, and our answer would be 5 and 19. How? Pi bond 1 2 3 4 5 6, and sigma bond is 1 2 3 4, because it will be going in resonance. Okay, and what happens is that 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 19. Okay, which molecule or ion out of the following does not contain unpaired electrons? So our answer is this one, because you can see like this, no unpaired electron. 1 minute. We have to write the configuration here. Sigma 1 is to sigma star 1 is to sigma 2 is to sigma star 2 is to 16 17 18. Okay, sigma 1 is to star 1 is to sigma 2 is to sigma star 2 is to pi 2p x2 pi 2p y2 sigma 2 p2 and 1 minute 2p z2 and 2 4 2 6 2 8 2 10 2 12 2 14, and then pi star 2p x2 pi star 2p y2 and sigma 2p z star 2. Okay, 2 4 2 6 2 8 2 10 2 12 2 16 2 18 2 4 2 6 2 8 2 10 2 12 2 14 15 16 17 18 19 20. So total there are 18 electrons. Okay, so this will be not present, but up till here, so there will be 18 electrons. Okay, so our answer goes to O2. MOT, molecular orbital theory. In which are the following molecules and all the bonds are not equal? So our answer is C2H4, because you can see here they are not equal. Okay, this is sp2, single bond is sp3, double bond is sp2, and triple bond is sp. Single bond sp3, double bond sp2, and triple bond is sp. Just learn this fact. In which of the following substances will hydrogen bond be stronger? So our answer is H2O. If the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, 4s2, the 4 electrons involved in chemical bond formation will be 3d2 and 4s2. Chemical bond, because chemical bond is formed by the electrons which are present in the periphery, so it will be 3d2 and 4s2. Which of the following angle corresponded to sp2 hybridization? That is 120 degree. 120 degree. The electronic configuration of 3 atoms A, B, C are given below. Answer the question 14 to 70 on the basis of these configurations. 1s2, 2s2 and 2p6 is HHELIBBCNOFNE. So it is Ne. First one, 1s2, 2s2, 2p6, 3s2, 3p3. NaMgAlSi P. Second one is phosphorus, 1s2, 2s2, 2p6, 3s2, 3d5. So it is chlorine. The stable form of A may be represented by the formula that is A, because it's neon and they generally does not combine or do not combine with the other as they are already stable. Okay. The stable form of C may be by the formula is like that, chlorine can form Cl2. Okay. The molecular formula of the compound formed by B and C, and when phosphorus and chlorine form, then they can form PCl5 or PCl3. So it will be 4. That is 4. Okay. The bond between B and C will be, because they both are non-metals, so it will be covalent bond. I think so, and it's correct. That is covalent bond. Covalent between non-metals like P, Cl, etc. Which of the following order of energies of molecular orbital of N2 is correct? So our answer is this one. Pi 2py greater than sigma 2pz greater than sigma star 2px equal to sigma star pi star 2py. Okay. Which of the following elements statement is not correct from the viewpoint of molecular orbital theory? 4. Because the order of energy of molecular orbital in N2 is not this. Okay, it is like sigma 2s2, sigma star 2s2, sigma 2p, sigma star 2px, sigma star 2p. Okay, and then others come, but it is not correct. But what is correct? Be2 is not a stable molecule because HHILIBE 8 electrons, and when we will form sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma pi 2px2, pi 2py2, then 2 2 4 2 6 and 2 8. And when you will be obtaining the bond order, then it will be half sigma minus pi electrons. So what you will get is 0. 0, or you will be not half. Okay, it will be only sigma minus pi, and it will be 0 because it's 4 minus 4. So BE does not exist. HE is not stable, but HE plus 2 is expected to exist. You can solve all these questions on the basis of molecular orbital theory, because HE2 is having 4 electrons. So when I will form, and when HE2 plus you are asking for, then it will be sigma 1s2, sigma star 1s1. So it will be bonding electrons minus anti-bonding electrons. So it will be 2 minus 1, that is 1. So it can exist, it may exist. Okay, bond strength of N2 is maximum amongst the homonuclear diatomic molecule belonging to the second period. Okay, so are not correct, so this one is not correct. Okay, which of the following options represent the correct bond order? So I am having a trick. For these questions. Firstly, write the 14, that is for N2, and bond order you will write here. Okay, and then this one, and then this one. 14, then 15, then 16, then 17. Okay, and here 13, 12, 11. Okay, so the bond order is decreased by 0.5. So for 15 it is 2.5, for 16 it is 2, and for 17 it is 1.5. Okay, and for 13 it is 2.5, for 12 it is 2, and for 11 it is 1.5. So when you will be doing this question, so you will get the answer of our question is 2, because you can see here O2 minus is having 17 electrons, O2 is having 16 electrons, and O2 plus is having 15 electrons. So it will be bond order of 2.5. It will be of what we can say, it is having 2, then it is having 1.5 bond order. Okay. So our answer is 2. The electronic configuration of outermost shell of the most electronegative element is fluorine. So it will be 1s, fluorine comes on HHELIBBCNOF, that is 9. 1s2, 2s2, 2p 5 6 7 8 9, 2p5, 2s2, 2p5. Okay. Among the following elements whose electronic configurations are given below, the one having the highest ionization enthalpy is ionization enthalpy is what it is. It is the in gaseous state, when we remove an electron from the gaseous atom, then the energy required is the ionization enthalpy. So near the nucleus it will be, when electron is present near the nucleus, then it is more, and when electron is far away from the nucleus, then it is less, because it will the nucleus will attract that electron with less attraction. But when it will be closer to the nucleus, it will be more attracted, as the जैसे पेरेंट्स का कंट्रोल अपने बच्चों पे रहता है, वैसे ही न्यूक्लियस का कंट्रोल इलेक्ट्रॉन्स पे होता है. सो हम कह सकते हैं कि जो इलेक्ट्रॉन न्यूक्लियस से दूर होगा उसको बाहर निकालना बहुत इजी है, लेकिन जो न्यूक्लियस के पास होगा उसको निकालना थोड़ा मुश्किल होगा. सो दैट द वन हैविंग द हाईएस्ट आयनाइजेशन enthalpy is this one. And the stable configuration also hinders the ionization enthalpy or removal of electron from the atom, because it is stable and it will not be it will not profound, or it will not go to disable its stability. So it will be, it should be being, it should wants to be being stable, so it will be in stable state, and you can see like this. Okay. In the following questions, 2 or more options may be correct. Okay. Which of the following has identical bond order? So our answer is Cn minus and NO plus, because for Cn minus what we can see is 6 plus 7 plus 1, that is 14 electrons, and NO, that is 7 plus 8 minus 1, that is 14 electrons. Okay, so bond order of the 14 electron system will be same. Which of the following attain the linear structure? Okay, so our answer is BeCl2, because you can see half 2 plus 2, that is 4 upon 2 equal to 2, that is Sp. Okay, and Sp is having linear shape. Sp, that is linear or straight. Okay, and our answer is Cs2. Okay, CO is isoelectronic with CO. 6 plus 8, that is 8 9 10 11 14 electrons, and the N2 is also having 14 electrons. So our answer is 1 and 2. And NO plus is having 7 plus 8 minus 1, that is 14 electrons. Okay. Which of the following species has the same shape? O3 is having like this. Okay. And our NO2 is also having, you can find the hybridization like this. Half 5 plus 1, that is 3, that is sp2, and it is having a electron present on it, so it will be like this, n and a lone pair on it, and then O and then O. Okay. And O3 is also same like that, O, double bond O, and a single bond and a lone pair. Okay. So our answer is O3 and NO2. Now, which of the following statements are correct about CO3 2 minus? So, firstly, we will find the hybridization. Half 6 4 plus 2, that is 6 upon 2, that is 3 sp2 hybridization. Okay. Which of the following are correct about CO3 2 minus? So our answer is the average formal charge on each oxygen atom is 0.67 units. All the CO bonds length are equal, because what we gonna do is, it is sp2 hybridization, then trigonal pyramidal. It will be 1 minute, C, double bond O, and double bond O. Okay. The diamagnetic species are those which contains no unpaired electrons. Which among the following are diamagnetic? So our answer is 14 electron system and 18 electron system. Okay. And no electron pairs are found which is unpaired. All are completely filled. Species having same bond order are F2 plus and O2 minus, because you can see like this, O2 is having how many electrons? That is 17 electrons, and F2 is 17 electrons. Okay. And when they are having 17 electrons, then when we will be finding 14, 15, 16 and 17. So bond order of this is 3, and this is 2.5, and this is 2, and this is 1.5. Okay. Which of the following statement are not correct? NaCl being an ionic compound is a good conductor of electricity in the solid state. No, it is not in solid state. It is in liquid state or in molten state, liquid or molten. So it is not correct. In canonical structures, there is difference in the arrangement of atoms. No, there is no difference of arrangement of the atoms. Okay, so all the best for your exams, but there are some questions of the match the following type, so we will do those questions. Match the species of column 1 with the type of hybridized orbitals in column 2. Okay, so SF4, that is half 6 plus 4 equal to 5, that is sp3d. Okay, so the answer is sp3d. And if5 is if5 half 7 plus 5 7 8 9 10 11 12 equal to 6, that is sp3d2. So our answer is sp3d2. And NO2 plus is half 5 minus 1, that is 4 upon 2, that is 2, that is sp. Okay, so our answer is 1 minute. Yes, our answer is sp. NH4 half 5 plus 4 minus 1, that is 4, that It is sp3. Okay, so our answer is sp. Okay, 3. And NO2 is having sp. Match the species in column 1 with the geometry or shape in column 2. So H3O plus, what we will do is 6 plus 3 minus 1, that is 4 sp3, but oxygen. Okay, so it will be what we can say is tetrahedral geometry, because it is sp3 and here it is a linear. Okay, and ClO2, when you will go with ClO2, half 7 plus 1, that is 4 sp3, and it will be 7 or 8, 7 and 8. So it will be B, that is angular, because 2 electrons pair will be there on Cl and O and O. Okay, and in case of NH4 plus, half 5 plus 4 minus 1, that is 4 sp3. Okay, so our answer is tetrahedral. H3O plus is tetrahedral, and this one is linear, and ClO2 is angular, and NH4 plus is tetrahedral. Match the species in column 1 with the bond order in column 2. So NO is having 8, 9, 10, 11, 13, 14, 15 electrons. So it will be bond order of 14, 15, 16, 17. Okay, 14 is having 3, 15 is having 2.5, and 16 is having 2, and 17 is having 1.5. So NO is having 2.5. Okay, and CO 8, 9, 10, 11, 13, 14, 14 electrons, so it will be 3. Okay, and O2 8, 8, 16, etc., then it will be 1.5. Okay, and O2 8, 8, 16, so it will be 2. Okay, match the items given in column 1 with the example in column 2. Hydrogen bond is present in HF, resonance is seen in O3, and ionic solid is LiF, and covalent solid is carbon. Match the shape of the molecule in column 1 with the type of hybridization in column 2. Tetrahedral is sp3, trigonal is sp2, and linear is sp, and sp2 is having double bond, sp is having triple bond, and sp3 is having single bond. Okay, this is for sp3, this is for sp2, and this is for sp. Okay, all the best for your examinations.